So let's talk about special products. We're still talking about products, so we're still doing multiplication. This is the section of your book where it talks about the FOIL method, which we are going to ignore. When it says FOIL, you just think in your mind distributive property. But I want to show you a couple of I guess really a couple of shortcuts, a couple of multiplication shortcuts, okay? So here's the first one. We've done these before the long way, and we said that whenever you're squaring a binomial like that, what it means is multiply it by itself, right? So what this would mean if we wrote it out the long way would be 3y plus 1 times 3y plus 1. I'm going to work this out the long way very, very quickly. I'm not going to actually finish the problem. I'm just going to do the first distribution so that you can recall what this looks like. 3y times 3y is 9y squared. 3y times 1 is 3y. 1 times 3y is 3y again. And 1 times 1 is 1. Okay, so I'm going to stop right there. And let's see if we can find a pattern or a shortcut that would take us from this to this. Now here's what I notice. The first term here, the 9y squared, came from 3y times 3y. And the reason I did 3y times 3y, the reason this is being multiplied by itself is because the first term was 3y and squared means do it twice. Same thing with the last term. We got the 1 because the last number was 1 and we did 1 times 1. Now I told you, do not do this problem by doing 3y squared and then 1 squared. Don't do the problem that way because that's not the answer. But it's half the answer. 3y squared is 9y squared and 1 squared is 1. So if you square the first and square the last, you've got half of the answer. So then the question becomes, where do these come from? They're the same. They'll always be the same if it's a squared problem. But could I go from this to this? Do you see how I go from this to this without doing all this distributive property? What if I just multiplied it by each other? What if I did 3y times 1? What's 3y times 1? 3y. And then I got 2 of them. So here's the shortcut. I'm going to write out the shortcut formula. I'm going to show you how to use it. The shortcut looks like this. If you have two things added together that are squared, here's the shortcut. You square the first thing. On the end, you square the last thing. And in the middle, you have the first thing times the last thing twice. 2 times the first thing times the last thing, and they're all separated by plus signs. Okay, so let's go back to our 3y plus 1 squared. Here's the shortcut. You square the first thing, and on the end, you square the last thing. And in the middle, you have the first thing times the last thing times 2. So 2 times the first thing times the last thing. So 3y squared is 9y squared. 2 times 3y is 6y times 1 is 6y. And on the end, 1 squared is 1. A very handy shortcut. Now, if you're looking at that and thinking to yourself, my God, that shortcut's awful, I never want to do the shortcut. I'll just do it the long way. That's fine. This is the long way. Doing it the long way will get you the answer every time. If you're like, nope, no shortcuts for me. I'm old school. Totally fine. But I'm still going to show them to you because they can be pretty big time savers. Now, this shortcut I gave you was a plus b squared. There's another shortcut for a minus b squared. When there's a minus sign in between them, it is almost exactly the same. You square the first thing, you square the last thing, And in between, 2 times the first thing times the last thing. The only difference is the signs. Instead of both being plus, it's minus plus. That's the shortcut for that one. Okay, so let's practice a few of these. We're going to do a couple of them, and if you still hate it, that's fine. No hard feelings. I just want you to be exposed to it. Okay, so here's our shortcut. Square the first thing. T squared. Then square the last thing. 2 squared is, what's 2 squared? 4. Thank you. And in the middle, first thing times the last thing. So t times 2 is 2t, and then double it. 4t. And there's our answer, separated by plus signs. Let's do a minus one. Here's our shortcut. Square the first thing. P squared. Square the last thing. Q squared. And then the middle, first times last, times 2. 2pq. And because this was a minus sign, instead of doing plus plus, it's minus plus. All right, square the first thing. Just squared. Square the last thing. And in the middle, first thing times the last thing. 2x times 5 is 10x doubled. 20x. Plus sign in the middle, so plus plus. Okay, square the first thing. X squared squared is, do you want to see me cry?
Okay, make it 4.
Yeah, let's make it 4. That's a good idea. Square the last thing.
Negative
49 y squared. And in the middle, first thing times the last thing. So 7y times x squared is 7x squared y doubled.
14
X squared y. Minus sign in the middle, so minus plus. Again, if you hate this shortcut, like this shortcut is worse than just doing it the long way. Number one, you are what's known as wrong. And number two, it's fine if you do it the old way, or the long way. It's not that old because you learned it 10 minutes ago, but it's fine if you do the long way. No hard feelings. I'm not going to call you out in front of everybody like all the time. I mean, I'm definitely going to do it sometimes. Not every time. Okay. Yes? No? Maybe?
No.
No to which part? Huh?
I'm just saying no.
Just no in general? Just no to everything? Huh. Now you sound like all the girls that went to high school with me. I don't even know what you're asking, and the answer is no. Yep, I've heard that before. Here's the other shortcut I want to show you. What if it's not something multiplied by itself, but it's really, really close? This is almost something multiplied by itself. The only difference is that the sign in the middle is different. Now, you don't have to know this word until next semester, but these are called conjugates when they're exactly the same, only one's plus in the middle and one's minus in the middle. You do not have to know that word until next semester. But when we get to next semester and I say it, you can be like, oh, I remember that word. So just like last time, I'm going to start off by multiplying it the long way. So this would be x times x and x times negative 4. And then 4 times x and then 4 times negative 4. Now what makes this an interesting problem is what happens when you combine them. When you combine the like terms, what are you left with?
Actually, x squared minus 16.
Very good. The minus 4x and the plus 4x are gone. So we're left with x squared minus 16. And there's our answer. The middle terms dropped completely out of this answer, and it turns out that happens every time you multiply two conjugates together. Anytime you multiply two things together that are exactly the same except one's plus and one's minus, the middle terms are always going to cancel out. They have to be exactly the same except for the sign, and the middle will cancel out.
Here's a crazy idea.
I like crazy ideas.
You already see a potential for two things timesing themselves in there, like 2x is equal to this function x squared.
Uh-huh.
Yeah, that's like times in the positive 4 and the negative 4.
Uh-huh.
That would get you negative 16.
Yes. So couldn't I just multiply the first things and the last things and then call it a day?
Okay.
I could. I could and I should. I don't want to tell you how to live your life, except that I do, and you should do it this way. That's exactly the same binomials, exactly, except one's plus and one's minus. So here's my shortcut. Multiply the first things together. 6t multiplied by 6t, 36t squared. Then multiply the last things. Positive 7 times negative 7. Negative 49. And I'm not even going to do the stuff in the middle because I know it's going to cancel out. Don't believe me? Do it yourself. 6t times negative 7, 6t times positive 7. That's going to be a negative 42t and a positive 42t. They are definitely going to cancel out. I'm not doing that. I'm just going to do the shortcut. They have to be exactly the same, only negative and positive. This is going to be really good news for you if you get something with everybody's favorite kind of number in it, the fraction. Sometimes we got to deal with a bunch of fractions, but this is not one of those times. They are exactly the same, only one plus and one minus. So, multiply the first things. Multiply the last things. You're adding, multiply. A fourth times a fourth. Well, it's a negative times a positive, so it's going to be negative. A fourth times a fourth, so we do 1 times 1.
Oh, 116.
1. 4 times 4 is 16. That's awesome. The grosser the problems become, the more you are going to like the shortcut, because it means less time dealing with a disgusting problem. I mean, it's beautiful on the inside, but like way on the inside. Hey, look, those are exactly the same, only one positive and one negative. So you multiply the first two. 3x squared times 3x squared is?
9
Good.
4
And then negative 5y times positive 5y,
is
negative 25.
negative 25 y squared.
There we go. Beautiful. Now, I cannot stress this enough. These shortcuts are 100% optional. They are truly shortcuts, meaning they are faster ways to do the problem, but they're not the only ways to do the problem. You can do the problem the long way by just writing it out and doing the distributive property. Totally fine. But I think you will find these shortcuts save you some time, especially this last one. This last one is a big, big time saver. Worth your while to learn how to do it. Any questions about these shortcuts?